Hey, all, today we're going to continue talking about right triangles. Last time we talked about Pythagorean theorem. We used Pythagorean theorem to find out how long a side was in a right triangle. But to use that, we would need to know how long two of the sides were. And so sometimes if we only know how long one side is, we can be saved a bit depending on how big the angles are. So we have these two things that we call special right triangles. There are two different types of special right triangles that we'll talk about. The first one is a special right triangle that has one 30-degree angle and one 60-degree angle. So if I have a right triangle and I have a 60-degree angle, we know the other angle is 30 because these three angles have to add to 180, and that's the only way that will work out since this one's 90. So if we know one angle is 30, we know the other one is 60. They all have to add to 180. That's the only way it'll work out. And so when we have a 30, 60, 90 right triangle, that's what we tend to call it. We have a special relationship between their sides. So I'm just going to draw one. Oh, that's pretty terrible, but it'll work. Let's call this the 30-degree angle and the 60. We have this special relationship between the sides of the right triangle, and it is that the side across from 30 we will say is 1. The hypotenuse of this triangle is going to be 2 times the size of my side across from the 30. And then the side across from my 60 is going to be the square root of 3 times my side. So we have this general, we call this sort of like the general 30, 60, 90 right triangle. And we know that triangles can be similar if we know that their angles are the same. So any 30, 60, 90 right triangle is going to be similar to this one. And that means we can write some proportions. So if I want to try and find the missing pieces in this right triangle, I notice I have a 60, so I put that 30 there. I'm going to draw a triangle that looks like it, the same orientation. There's my 60, there's my 30. And I'm going to label it using these three values. So the hypotenuse is 2, the side across from 30 is 1, and the side across from 60 is root 3. And so these two should be similar right triangles. One of them is going to be smaller than the other, but they're similar because they have all the same angles, so we can write proportions. So let's first solve for x. I want to figure out how long is this side that's x. Well, if I look at the two triangles, that side is related to this side, that's 2. So I'm just going to go ahead and write a fraction, x over 2. And then I have to see, okay, well, I know how long this side is. I don't want to use y because I don't want to have two variables in my proportion. So I know that this side is 7 root 3. X came from this triangle, so 7 root 3 can go on top of a fraction. And it's related to this side. And so I get a proportion, much like we got in the last unit when we talked about similar triangles, or we talked about proportional parts in triangles. And so we can solve this proportion for x. I can actually, I'm just going to cross multiply. So I get root 3 times x. I get 2 times 7 root 3. When we're multiplying with square roots, I can multiply the stuff outside the square root. So I can actually do 2 times 7 and get 14. Then I'm going to divide both sides by the square root of 3. And when I do that, I have a root 3 on the top and 1 on the bottom. So those things are going to cancel, and I can find that that hypotenuse is 14. So I'm just going to go ahead and put 14 over here. And so I can do the same thing to find y, or I can say, well, hang on. If y, or if x is twice as big as this side, if this hypotenuse is twice as big as this side, then x should be twice as big as y. So if x is 14, then y is 7. It's half as big. Or I could set up another proportion. I could say, let's say 14 over 2, and y over 1. If I solve that, I would get y to be 7. So let me set up another one here. I always start with drawing another triangle, and there are other methods. This is just the method I use. I draw it in the same orientation as the triangle I have, and I label the sides based on our general special right triangle. So across from 30 is 1, across from 60 is root 3, and across from the hypotenuse is 2. And then I can set up and solve a proportion. So if I want to find A is related to root 3, so I'm going to write A over root 3. And then I want to write another fraction with 6. I don't want to use B because I already have a variable, so I'm going to say 6 goes with 2. And so we can cross multiply. And we don't really need to cross multiply. The more you do this, the more you'll get comfortable with it. In this case, I could just multiply both sides by root 3 so that those two root 3's cancel. And I get 6 times root 3 will give you a decimal, so we're just going to write it as 6 root 3 over 2. And then I want to simplify that 6 divided by 2 and make it 3 root 3. If you're getting stuck with the square roots, that's okay. This takes some practice. Just make sure that you ask me for some help if you need a little help managing that. And then I could find B. I know that my hypotenuse is twice as long as this side, so if my hypotenuse is 6, then B must be half as big. That one's kind of a nice, easy one to get. So we have another special right triangle, and that special right triangle occurs when we have two 45-degree angles. So whenever we know we have one 45-degree angle in a right triangle, we're going to have two. Again, all three angles must add to 180. So if I have a 90, a 45, then the third one must be 45 as well. These are called isosceles right triangles. Isosceles triangles have two sides that are the same length. So we do have a special or a generic or a general 45, 45, 90. That's what we call it, 45, 45, 90. Or you can call it isosceles, but 45, 45, 90 works. The two legs, the two sides across from the 45s are going to be 1. They're the same length, so we'll call them 1. And then the hypotenuse is going to be the square root of 2. So again, I have similar triangles. They have the same angle measures. I can use proportions to figure out how long the sides are. What's really nice is that in a 45, 45, 90, if I know one of the sides across from 45, then the other one should be the same. So right now we already know that y is 9. And then I can set up a proportion. I can do 9 over 1. And I can do x over root 2. I can cross multiply, or I can just multiply both sides by the square root of 2. When I do that, those square roots of 2's cancel. I multiply the top of my fraction here by the root 2. I'm going to get a decimal, so I'm just going to leave it as 9 root 2. And then I don't need the divided by 1 because anything divided by 1 just stays the same. So again, for all of these, my strategy is to draw the general triangle. And then in the 45, 45, 90s, they're kind of nice because if you know, again, if you know one side across from the 45, then you know the other side across from the 45. They're the same. That's what that's telling us, the 1 and the 1. So y here is 2 root 2. I don't have to do a lot of solving. To get x, I could set up a proportion. The more you do this, the quicker you can get at it. And of course, the better you'll get at it. But I'm going to do 2 root 2 over 1. And I'm going to do x over root 2. I can cross multiply, or I can multiply both sides by root 2, whichever way you want to do it. X times 1 is just going to be x anyways. I get 2 root 2 times root 2. And so just like before, when I could have, where was it? When I could have the 2 and the 7 interact, but they don't interact with the root 3, now I can have these two square roots of 2 interact. The square root of 2 times the square root of 2 is just 2. If you didn't know how to do that, you can use your calculator. That's fine. Square root of 2 times the square root of 2 is 2. So here I get 2 times 2, which is 4. So we have our two general right triangles. I'm going to draw them one more time. I have a 30, 60, 90. And I have a 45, 45, 90. And I use them to set up proportions to find missing sides. So what I want you to do, or I'm going to ask you to do, is answer these 4 questions. I'll just ask you to find both sides in each one. So make sure you watch all the way to the end and you put your answers in when I ask for them. Of course, if you need help with this, please raise your hand. Use the examples as a guide, but please raise your hand if you need my help. I'll be happy to help you. As always, you're going to get better at this by doing practice, so make sure you do the practice when you're done. Good luck.